All right, so let's look at problem number 12. What is the molecular formula of a compound whose molar mass is 34.0 grams per mole? All right, so if you look at this one right here, you should be able to get the molar mass, right? So, for example, H2O2. How do you do the molar mass? Again, just count the elements. I mean, write down first the elements, count them. So you got two H's, two O's, and then you multiply them by their atomic masses. So this is 1.01, so we'll just do 1, all right? Round it off to 1. 2 times 1 is 2, okay? Oxygen is 16, so it's 15.999. We'll just round it off to 16. 2 times 16 is 32, and you add them all up, it's 34. All right. So you might think that H2O2 is already the answer, but it's not. Okay. Why? Guys, if you calculate the molar mass for all of these examples right here, you're gonna get 34. So for example, let's do the last one. NeH14. Right. So NeH. I got one neon, 14 H's. Right. The atomic mass for neon is 20.1. So let's just do 20. All right. And then this hydrogen again is just 1, right? So 1 times 20 is 20. 14 times 1 is 14. If you add it up, it's 34. Okay. So all of these actually have 34. Okay. So can all of them be the answer? Well, let's look at the problem in detail. It says there, what is the molecular formula of a compound? So molecular formula, that's our key there. Remember, guys, when we say molecular formula, all right, the subscripts, you can still divide it by a certain number and make them lower. So again, in a molecular formula, you can find a common number to divide all the subscripts, okay, and make them lower. So let's see. In the first one, can you lower the subscripts there? Yes, by dividing it by 2. So I divide the subscripts by 2 and I get HO. Okay, so H2O2 is a molecular formula. All right. How about B? Look at the subscripts there. So N has a subscript of 1, H is a subscript of 4, O is a subscript of 1. Can you find a number to divide 1, 4, and 1 and make them lower? No, unless the number is 1, all right? Other than 1, no. So B is actually what you call an empirical formula. Okay, remember that? Empirical formula are the simplest formula, which means the subscripts, you cannot lower it anymore. All right. How about the next one? Same thing. 1, 2, and 1. Can you find a number to divide 1, 2, and 1 to get it lower? No. So again, NH2O is also an empirical formula. All right. Okay. All right. And then finally, let's look at D. 1 and 14. Can you find a number to lower 1 and 14? No. Therefore, this is also an empirical formula. So, it's not B, it's not C, it's not D. The answer has to be A. Because again, H2O2 is a molecular formula, right? And its empirical formula, HO. This is your empirical formula right here. Okay? All right. That's number 12. Okay? That's number 12 right there. Okay. All right. Let's look at number 13. All right. It says here during a lab experiment, 55.95 grams of H reacted with 445 grams of oxygen to form water. What is the empirical formula of water? Well, all right. We already did a few steps here before. Remember, this was like percent composition where step one would be to turn it into grams. So step one would be to turn it into grams. But look closely. The given is already in grams. So again, If we did this from before, step 1 was, right, turn to grams. Okay, if we had percent, you would do first turn it to grams, but this is already in grams, so we go straight to step 2. Okay, in step 2, we have to turn it into moles. Okay, so we're gonna change this into moles now. All right, so let's get the first one. So 55.95 grams of H. All right, so how do you turn this into moles? Remember, we have to do those boxes in squares, right? Yeah, and then there's nothing here, remember? Nothing underneath the given. Okay, and then we have to put in a conversion factor. So how do you do this again? Remember, the conversion factor, if ever you see grams, is 1 mole is equals to the molar mass. So again, whenever you see the word grams, remember our conversion factor is 1 mole equals to how many grams of whatever that is. And this is the molar mass. Okay. Again, this is your molar mass calculation. And you should know this by now. All right. So, okay, since it's just H, let's just look at the periodic table. The atomic mass of H is 1.01. So, where do you put that? Again, boxes diagonally across, they have to have the same unit. So the 1.01 grams of H goes at the bottom. All right. Now, just to make my life easier, I'm just going to round this off to 1. All right. So 1. So where does 1 mole go? At the very top. Right. The grams cancel out like in algebra. 55.95 times 1 divided by 1 gives me what? Gives me, of course, 55.95. Okay, and this is moles of H. Okay. All right. Let's do the one for oxygen. So same thing. Draw those grids. Nothing goes underneath here. The given goes in the very first top box, which is 444.95 grams of O. Right? We're going to round off. So 16 grams is the molar mass, 16 grams of O for every 1 mole. The grams O cancel out. 444.95 times 1 divided by 16 is 27.75 moles of O. Okay. All right. Let's do now step 3. All right. If you still remember, step 3 would be dividing the answers by the smallest one. So step 3, divide by small. Okay. So let's write that down. So H, what was the answer for H again? Was 55.95. Okay. And what was the answer for O? O was 27.75. Okay. Look at those two answers. Which one is the smaller one? Of course, the smallest one is 27.75. So I'm going to divide both of them by 27.75. Okay. All right. So H 55.95 divided by 27.75. H is equals to 2.01. Let's just go 2.0. And O obviously is equals to 1. All right. And then remember, step 4 would be multiply until whole. All right. So make it whole. But it's already a whole number. So that's going to be our subscripts. That's already the answer right there. The answer is right there. And that's going to be your subscripts. So the final answer is H2O1. But 1 is invisible. So the formula here is simply H2O. You got it? All right. Let's look at problem number 14. Oh, this one's easy. Which of the following supports the law of conservation of mass? Remember, guys, in the law of conservation mass, it states there, mass is neither created nor destroyed, but only changed in form. And that's the reason why we balance chemical equations, just to make sure that the law of conservation of mass holds true. So if you look closely here, and when you look at our chemical equations, you have to know that the total mass in the reactant side is equal to the total mass of products. But right, we can't measure the mass most of the time when we're doing chemical reactions. So when we're looking at chemical equations, we need to make sure that the total number of atoms in the reactants is equal, okay, to the total number of atoms in the product. So the correct answer here is letter A. All right. Let's look at question number 15. All right, the diagram below represents the chemical equation reaction that occurs when methane gas reacts with oxygen gas. Based on the diagram, for every molecule of CH4, that's our methane, how many molecules of O2 are used? Okay, so look at the diagram. It's very clear right there. For every one of this, that's your methane, you need two of these. That's your oxygen right there. Okay, which produces one molecule of CO2 that and produces two molecules of H2O. See it? Or if you want, you can just look at the chemical equation, which is right here. Okay, how can you tell from the chemical equation? Remember, guys, the coefficient, okay, in a chemical equation tells you the number of molecules, okay, molecules, there's an S there, or the number of moles, whichever is the one you're using. So if you look here, you can clearly see that there's a 2, okay, there's a 2 in front of O2, okay, when you have one methane. So the answer here is 2 O2, or 2 molecules of O2, right? Right there. All right. Let's look at question number 16. All right. Question number 16. What is the coefficient for water after the equation is balanced? All right. So this is balancing equations. So how do you balance equations again? First thing you need to do is divide the equation in half, right? And then you start counting atoms. C, how many C's you have? 8. H, how many H's you have? 16. O, how many O's you have? 2. On the right side, you have C equals to 1. H is equals to 2. And O, if you look closely, guys, there's two O's right here and right here. You have to show those two O's separately. 2 and a 1, that gives you a 3. So you know that there are two O's appearing in two different places. All right. So remember, you look for an element that is not equal, and that's the one you want to balance. But remember, you do the O's last, and if an element appears more than once, like O right here, on one side, twice or more than once, you do those last as well. So in our case, we'll do the O's last. So we can start with C, or we can start with H, because look, C is not equal. All right, H is not equal as well. So it's up to you which ones you want to start with. Okay, let's just start with C. All right, so let's try to make C equal. Let's balance it out. So how do you balance it out? Again, you have to look for the low side. Which is the low side? It's the right side right here. Okay, and how do you balance it? Remember, the rule is you look for a number to multiply to the low side to make it equal. So I need to multiply a number to the 1 to make it equal. And how do you get that number again? It's simply, guys, the high side, which is 8, divided by the low side, which is 1. So 8 divided by 1, the answer is 8, and that's the number that you need, right? So this is multiplied by 8. 1 times 8 is 8, all right? So now they're equal, all right? But we're not interested in the final answer. We're interested in the multiplier because that multiplier becomes your new coefficient. So 8, put it right here. All right. So let's look at that 8. Does it multiply anything else other than the C? It multiplies the C and then it multiplies the O. Right. So do I just multiply the O like this by 8? Okay, to make it 24? That's wrong. Okay. Remember, look closely. O appears in two different places, right? And you only multiply one of the O's. So this O is the one that gets multiplied. So 2 times 8 is 16. 16 plus 1, the total now is 17. You see it? All right. Let's do H. All right. I got 16 on one side. Okay. I got 2 on one side. So again, I need to find the lower side, which is this. Multiply that low side by a number to make them equal. Again, it's the high side, which is 16, right? Divided by the low side, which is 2, and I get 8. You see it? All right. So again, it's going to be 8. So multiply this by 8, and I get 16. They're now the same. All right. Again, that 8 that you used to multiply becomes your new coefficient right here. All right, look at it. It multiplies the H. It also multiplies the O. This time, guys, it's the other O. So times 8, you got 8. 16 plus 8, the total is now what? 24. Right. Now look. You got 24 on one side. I got 2 on the other side. So what number do you multiply to the low side? 12 to get a 24. And there you go. So that 12 now is your new coefficient for O. Check if it multiplies anything else. No, therefore I am done. The blank is a 1. Okay. So what is the coefficient for water here? The coefficient for water, the answer here is 8. You see it? And that is question number 16. All right. All right. Let's look at question number 17. Okay. Which set of coefficients will balance the equation? All right. If you look closely, guys, divide this in half. All right. If you look closely, look, the other side already has coefficients. You see it? It already has coefficients. So we just need to really quickly eyeball this. All right. C here is 1. H is 4. Okay. And then O here on the left side is 2. On the other side, let's figure this out. I got C1. H here, look closely, guys. H, there's a 2, but again, the big 2 multiplies the H. So again, I got a total of 4 H's. Okay. All right. O, look closely, guys. I got O in 2 places. Here, 2. And on the other side, I got this O, but it's also multiplied by the coefficient 2. So this is a 2, a total of 4. All right. So look closely. The C is equal. They're equal. The H, they're all equal. All right. So the only one's not equal is the O. So I need to find a number to multiply to O. Okay. To multiply to O to make it equal. So that's going to be a 2 to make it a 4. So the coefficient here is a 2. So what's the coefficient for CH4? It's just a 1. So that is the coefficient that will balance the equation. So the answer there is 1 and 2. All right. Okay.